Alright guys, if you notice this looks a little bit different, I got a fancy new pencil to go with the iPad that the district gave us. So we're going to see how it works recording the notes on our iPad. So we are looking at 6.9 today, and 6.9 deals with the second fundamental theorem of calculus. So it says, suppose the function f of x is defined by an integral such that f of x is equal to the integral from 0 to x of f prime of t dt on the interval from 0 to 4, and the function f is given in the figure right there. So if I'm trying to find my f of x, which is the integral from 0 to x, let's fill in this table. So I'm going to take that f of x is equal to the integral from 0 to 0 of f prime of t dt. And if we're going from 0 to 0, that is a 0 integral, so our f of x is just going to be 0. So then our next one, we're looking at f of x, and this one equals the integral from 0 to 1 of f prime of t dt. And so this time when we're going from 0 to 1, what we're looking at is this rectangle right here. So this rectangle area is a 1 by 1 rectangle, so the area of that is just going to be 1. So the next one I'm looking at is f of x, and it's going to equal the integral from 0 to 2 of f prime of t dt. So this time when we're going from 0 to 2, it's going to be that red box. And we're also going to take into our area this triangle that's above the axis and this triangle that's below the axis. And you'll notice that these two triangles just cancel each other out. So my area here is still just going to be the area of 1 from that red box. So the next one that I'm looking at is from 0 to 3. So f of x is equal to the integral from 0 to 3 of f prime of t dt. So now when I'm going from 0 to 3, I'm adding this shape right here, which is going to be a trapezoid. So my base 1 is this right here, which is 1. My base 2 is this right here, which is going to be a 1/2. I'm going to have the 1/2 in front of it, and my height is the whole 1. So what I'm looking at is 1/2 times 1 plus 1/2 is going to be 3/2. So I'm looking at 3/4. And it is a negative 3/4. Oops, switch the colors on us. It is a negative 3/4 because it's below the axis. So I'm looking at 1, the greens cancel each other out, and the negative 3/4, so 1 minus 3/4 is going to give me 1/4. And my last one that I'm looking at here is f of x is equal to the integral from 0 to 4 of f prime of t dt. So I'm adding this last little triangle bit right here. So that last little triangle bit, that is going to be a 1/2 times my height right here is 1/2. And this whole base right here is just 1. So 1/2 times 1/2 times 1 is going to give me a 1/4, and it is a negative because it is below the axis. So 1 minus 3/4 minus 1/4 is going to give me 0. So let's look at part B right here. Part B says the integral from 0 to x of f of t dt. So if I were to take this integral, how we are used to taking integrals, well, an integral and a derivative are going to cancel out. So I'd be left with f of t, and I'm going to go from 0 to x. So what I'm really looking at is f of x minus f of 0. And you'll notice that from up here, our f of 0 is just 0. So that kind of cancels out, and I'm really just left with f of x here. So if I were to take b and then go and take the derivative of it, well, the derivative of f of x gets me back to my f prime of x. So what we're talking about today is the second fundamental theorem of calculus. And the second fundamental theorem of calculus says that if f of x is equal to the integral from a to b of f prime of t dt, if it's a continuous function and g and h are differentiable functions, so sometimes instead of it going from a to b, it could go from a g of, not x, a g of t to an h of t. So that's just saying that both of your bounds are also differentiable. Then f prime of x is equal to this right here. So breakdown of what this equation right here means. What I'm going to do is I'm going to plug the top bound in to my whatever f prime of t is, and then I'm going to take the derivative of that top bound. So that would be my h prime of t, and I'm going to multiply those. Then I'm going to plug the bottom bound into my f prime of t, and I'm going to multiply by the derivative of the bottom bound, which would be my g prime of t. And then the last part is that I would just take part 1 and subtract part 2 from it. So we use this theorem specifically when we have an integral that has a variable on at least one of the bounds, or if we're taking the derivative of an integral. That is why we use this theorem. So let's look at a practice problem right here. So this says to find f prime of x, and it tells us that f of x is equal to the integral of this. So let's use our steps right there. I'm going to plug in my top bound, which is x. So that means I'm plugging it into this equation right here. So I'm going to have 3x squared plus 4x. And then I multiply it by the derivative of the top, which the derivative of x is just 1. So I'm multiplying it by 1. And then I'm going to subtract, repeating the process on the bottom. So I'm going to plug 2 into my function. So 3 times 2 squared plus 4 times 2, and then I'm going to multiply that by the derivative of 2, which is just 0. So what you'll notice is this whole part goes away, and I'm just left with 3x squared plus 4x for my answer here. So that is what we are doing here. And let's look at our next example. So let's go to our next page here. Ooh. Still learning how to use this new pencil. Okay, so right here we're taking the derivative of this integral, so that means we're doing our second fundamental theorem of calculus. So I'm going to plug the top bound into my equation, so I'm going to have a sine of x cubed, and then I'm going to multiply that whole thing by the derivative of x cubed, which is 3x squared. Then I'm going to subtract from that the same process on the bottom. So the bottom, that means I'm plugging in my pi over 2, so sine of pi over 2, and I'm going to multiply that by the derivative of pi over 2, which is just 0. So once again, my whole bottom part cancels out, and I'm going to simplify this top part and write it as 3x squared sine of x cubed. So there's my answer for number 2. All right, if I am looking at number 3, what we are doing here is just a normal integral. So in that normal integral, we are going to use that power rule that we're used to. So I'm going to have 5t to the 10th over 10 plus 3t cubed over 3, and I'm going to go from 0 to 1. So cleaning that up, 5 over 10 is 1/2 t to the 10th, plus those 3's cancel out, and I have just t cubed from 0 to 1. So what I'm going to do here is 1/2 times 1 to the 10th plus a 1 cubed minus 1/2 times 1, sorry, not 1, now we're looking at 0 to the 10th power plus 0 to the 3rd power. So that whole part goes away, and I basically just have 1/2 plus 1, which is equal to 3/2 right there. So make sure that you are paying attention to when it's asking for the derivative and when it's just a normal integral. You really need to make sure that you are paying attention to that. Okay, let's look at number 4 here. We're back to finding our derivative, so we're back to the second fundamental theorem of calculus. So I'm going to have my h of t, but I'm going to plug in 4x. So I'm going to have h of 4x, and I'm going to multiply that by the derivative of 4x, which is just 4. And then I'm going to subtract from that the same process with the bottom. So I'm going to have h of 1 times the derivative of 1, which is just 0. So the bottom part cancels out, and on the top, I'm going to clean that up a little bit. 4h of 4x. All right, looking at number 5. Once again, it says take the derivative with respect to x. So let's start with our top. I'm going to have, instead of 5t, it's going to be 5x. And I'm going to multiply it by the derivative of x, which is just 1. And then I'm going to subtract the same process on the bottom. So the bottom is a negative x, so it's going to be 5 times a negative x. And then the derivative of negative x is negative 1, so that's going to be a negative 1 there. So cleaning it up, I have a 5x here, and then minus, well, a negative x times a negative 1 makes it a positive x, so minus 5x, which is going to give me my answer of 0. All right, 6, d over dx. Once again, that means that we need to take the derivative. So I've got t squared minus t. I'm going to plug that 3x in, so I'm going to have 3x squared minus 3x. And that I am multiplying by the derivative of 3x, which is just 3. And then I'm going to subtract the whole process on the bottom. So the bottom is 2x squared minus 2x, bracket, times the derivative of 2x, which is just 2, so times 2. So cleaning it up, this is going to give me a 9x squared minus 3x, and I have a 3 that I'm multiplying that by, minus 2 times my 4x squared minus 2x. So 3 times 9 gives me 27. So 27x squared minus 9x, and then I'm going to distribute a negative 2 over here. So this is going to be negative 8x squared plus 4x. So 27x squared minus 8x squared gives me a 19x squared, and a negative 9x and 4 gives me minus 5x. And our last problem right here, I don't see any x's in my bounds or any derivatives, so this one is just a normal integral. So that means I'm looking at 3x to the 6th over 6 plus 2x squared over 2, and I'm going to go from negative 3 to 4. So 3 over 6 I can simplify to 1/2 x to the 6th. The 2's cancel out here, so I have plus x squared, and it's from negative 3 to 4. So plugging in my top bound, I'm going to have 1/2 times 4 to the 6th plus 4 squared. And then I'm going to subtract, plugging in the lower bound. So 1/2 times a negative 3 to the 6th plus a negative 3 squared. And you can go through and simplify all of that, and when you simplify it, you should get 3,381 over 2. All right, that is it for this video, this set of notes. There is a Go formative that goes with this, so please make sure that you complete that Go formative. If you have any questions, email me or ask me in class or come to my tutoring times. And you guys have a good day.